We have been talking about similar figures and the fact that similar figures have sides that are proportional and corresponding angles that are equal. And now, because the reverse is true, because we know, if we know that two figures are similar, and we're not trying to prove that they're similar, we can actually use the characteristics of similar figures to find a missing side. So for example, we obviously know that the corresponding angles are equal, and because the sides are proportional, we can use a proportion to find a side that is missing. So in this case, we have a rectangle that is 25 centimeters by 10 centimeters, and a smaller version of the rectangle, which is 11.5 centimeters by something that we don't know. So when we're solving one of these kinds of problems, we need to use a proportion. And there's actually several ways that we could correctly do the proportion. So what we're going to do is write a word ratio first, like we did in class with the just proving that two figures are similar. And in this case, we're going to decide which sides we're going to compare. So we could either compare the two sides of one rectangle with the two sides of the other rectangle. So we could do 25 over 10 equals 11.5 over x, or 10.5 over 10 over 25 equals equals x over 11.5. Or we could compare one side of this rectangle to the corresponding side of this rectangle and then have that over, that's 10 over x equals 25 over 11.5. As long as you're consistent, it doesn't matter, because you will still get cross products that are equal and we can still solve for the proportion. So in this case, excuse me, we're going to put, let's compare one rectangle to the other. So we could do 10 over x. We're going to say, let's say large rectangle over short rectangle over small rectangle, and that could be our word ratio. So the large rectangle over the small rectangle. So 10 over x equals 25 over 11.5. And then we're going to solve the proportion, solve for x. Again, if we set it up differently, we're still going to get the same numbers that are our cross products. They would just be listed differently, but we're still going to be multiplying the same numbers together. So we multiply going across, so 25 times x, 25x, equals 10 times 11.5, 25x. We're solving just as any equation. 10 times 11.5 would be 115. And then we divide by 25, we actually are going to get 4.6, which means that one side, the x, is equal to 4.6. So you'll notice we don't always have to be multiplying by, we don't have to have that common ratio of a whole number. It could be any decimal. So it's not, we're not always going to be multiplying by 2, multiplying by 4, and so forth. Okay, now, with rectangles, relatively easy because we only have two sides that are different measurements. Let's look at what happens if we do the same kind of a thing. With two triangles, I actually have more measurements that we're looking at because we have three different sides of each triangle. And so I need to find, in order to find a missing side, I have to pick at least one pair of corresponding sides that both have a number. So I can't find these two sides, I can't use these two sides and these two sides because I don't have numbers for both of a pair. All right, so what I'm going to do is I'm going to first try to find x. So in this case, let's use as our word ratio large triangle over small triangle. So I'm going to use the number, whatever number is in the large triangle, I'm going to use that number as well as the corresponding side on the small triangle. So we need to use these two sides because I have both measurements for that. So 4 over 2 is equal to the one that has the x. So 4 over 2 is equal to 3 over x. And then I'm going to solve for x. So I do 4 times x is equal to 2 times 3. 4x is equal to 6. And then I'm going to divide both sides by 4. And it's going to be x is equal to 6 over 4, which is 1 2/4 or 1 1/2. 1 1/2 or 1.5. So x is equal to 1.5. So I would go ahead and label that on the right side. And now I can either go back to my 4 and 2, or I could actually use the 3 and the 1.5 as my first ratio, and then I need to use a ratio that has the other missing side. So now I'm finding y. So I'm going to use, let's see, we'll go back to the 4 over 2. 4 over 2 is equal to y over 1. And then 2y is equal to 1 times 4. 2y is equal to 4. And then I divide both sides by 2. And I get x is equal to 2. So, oh, sorry, that's actually a y. It should be y is equal to 2. It is important to keep track of which variable you're using because those stand for different numbers. So y equals 2. So I now have a triangle that has measurements of 2, 3, and 4, and this has 1, 1.5, and 2. And so that is how I find a missing side of a similar figure.